KA20403 Engineering Survey, prepared by Group 3, prepared for SRTS Dr. Asmawan Muhammad Sarman. A very good day. Welcome to Group 3's presentation video. Our topic for this video is contour. Before we discuss the topic, allow me to introduce our group members. Group 3 consists of 5 members, whom are me, myself, Khadija, Monica, Alfreda, Elisa, and Farahanim. There will be 5 parts in this video, starting with introduction, description of contour, elements in contouring, examples and info on contour, and lastly, the closure. So, for the introduction, you must be wondering, what is contouring in survey? Generally, contouring in survey is the process to obtain the elevation of various points on the ground and fixing these points of same horizontal positions in the contour map. The first known maps to include geographical features were found in ancient Rome. It would be thousands of years before cartographers, who are map makers, could chart large areas of terrain with any real accuracy. Contour lines, as we know them today, came into popular use in the mid-1800s, along with the rise of resource extraction industries like mining and logging. Have you ever noticed squiggly lines all over your hiking map? Other than the obvious trails and rivers, these squiggly lines are contour lines. What are the uses of contour map other than for hiking? Contour maps are immensely useful for engineering works. First and foremost, contour lines are critical to understanding the elevation profile of your terrain or a particular land formation. Second, civil engineers usually study contour map to find out the nature of the ground to identify the perfect site for the project works to be taken up. Third, with contour map, it is possible to find out the profile of the ground along that line. This is useful in finding out depths of cutting and filling if formation level of road or railway has been decided.
And now, I would like to talk about the descriptions of the topic. Contouring can be described as the process of tracing contour lines on the surface of the earth, while contour maps is the maps upon which these lines are drawn. Contour maps give an idea of the altitude of the surface feature as well as their relative positions in plan. Therefore, a contour map serves the purposes of both a plan and a section. Contour interval is the constant vertical distance between two consecutive contours. Do you ever wondering what factors did contour interval depends upon? The contour interval depends upon the following factors, which is first, the nature of the ground, second, the purpose and extent of the survey, third, the scale of the map, and lastly, the time and expense of field and office work. And this is the common values of the contour interval adopted for various purposes. First is for large-scale maps of flat country, for building site for detailed design work, and for calculations of quantities of earthwork, 0.2 to 0.5 meter. Second, for reservoirs and town planning scheme, is 0.5 to 2 meter. Third, for location survey, is 2 to 3 meter. Last but not least, for small-scale maps of broken country and general topographical work, is 3 meter, 5 meter, 10 meter, or 25 meter.
Now, I am going to present the characteristics of contouring. All points in a contour line have the same elevation. Flat ground is indicated where the contours are widely separated. A uniform slope is indicated when the contour lines are uniformly spaced, and a plane surface when they are straight, parallel, and equally spaced. A series of closed contour lines on the map represent a hill when the higher values are put inside, and it indicates a depression when the higher values are put outside. These pictures are the representation of the last two characteristics, where the left figure represents the hill and the right figure represents the depression. Next is the method and procedures. In direct method, the contours to be located are directly traced out in the field by locating and marking a number of points on each contour. The procedure for direct method are as follows. Temporary benchmark is established near the area to be surveyed with reference to a permanent benchmark by taking flying levels. The level is set up in a position that the maximum number of points can be commanded from the instrument station. The height of instrument is determined by taking a backside on the benchmark and adding it to the reduced level of the benchmark. The staff is held on an approximate position of point and then move up or down the slope until the desired reading is obtained. The point is marked with a peg. The new height of instrument and the required staff reading are calculated, and the process is repeated until all the contours are located. The position of the contour points are located suitably. The points are then plotted on the plan and the contours were drawn.
For indirect method, this method's contouring is sometimes known as contouring by spot level. Indirect method of contouring is commonly employed in small-scale survey of extensive areas. This method is cheaper, quicker, and less tedious as compared with direct method of contouring. There are three main methods for indirect. First one is by square. Whole area are divided into a number of squares. The square should not be same size. The corner of square are pegged out and the radius level of this point are determined with a level. The square are plotted and radius level of the corner are written on the plan. The contour line are then interpolated. Next is by the cross section. The cross section perpendicular to the center line of the area are set out. The spacing of the cross section depends upon the contour interval, scale of plan, and the characteristic of ground. Point of silent feature along the center line and cross section are also located. First, plot the center line and cross section on the desired scale and enter their radius level. The contour are then interpolated with respect to this radius level. Last but not least is by tachymetric. A number of radial lines at non-angular interval are drawn on the ground and the position of points at equal distance are marked. Use the tachymetric formula to calculate radius level and horizontal distance. Then a point are plotted on the plan. The contour plan are then interpolated. That's all for the direct and indirect method. Thank you.
For example, counter survey is carried out at the starting of an engineering project. For instance, in railways and road construction site. Compass, theodolite, plane table, and measuring tape are normally used during contour surveying. Method of squares, method of cross-section, and radial line method are the usual methods used during contour surveying. A civil engineer studies the contours and finds out the nature of the ground to find suitable site for project work to start. For example, the routes of the road, railway, canal, or severe lines can be decided so as to minimize and balance the earthworks.
From this video, we can conclude that contour in surveying is the line of intersection of a level surface with the surface of ground. These videos are made in order to summarize the information that need to be known regarding the experiment involving contouring. We hope through this video it can help those who wanted to learn more about contouring and its experiment to be able to understand it better and conduct the experiment successfully. That's all from our group. Thank you.